Hello and welcome back. For this video we'll be discussing factoring trinomials, but when our leading coefficient is a 1. So if you look right here, we have two binomials being multiplied together, and when we expand it we get this quadratic trinomial, and the number out in front, the leading coefficient, is a 1. First thing we need to know about is standard form of a quadratic. Now right here we have ax squared plus bx plus c and equals 0. We don't necessarily have to have it equal to 0, but everything that's on this side is considered to be the standard form of a quadratic, and what we're actually looking at is a quadratic trinomial. For this lesson though, we're going to assume that the a value, which is this one out in front, is going to be a 1. Alright, so down here we have an example of two binomials being multiplied together, and when I multiply the first x with this first x, I get the x squared. Then I take this x and multiply it with the negative 5, and we get a negative 5x, which is right here. And now we're going to multiply this second term here with the first x, and that will give us a positive 2x. Then we're going to distribute it over to the negative 5, so 2 times negative 5 will give us negative 10. Now these two numbers in the middle will combine to make negative 3x. So this ends up being our quadratic trinomial that was created from the product of the two binomials, but noticing that the leading coefficient here is a 1. There's also some things you need to know when solving or factoring trinomials, and that is the a value, at least in this place, is going to be a 1. The b value, we need to recognize what that is, which is right here, and the c value, which in this case is negative 10. So in order to factor, you need to know what those three values are. Once you know what they are, then you can proceed with factoring. Example 1. First thing I'm going to notice is I have a leading coefficient of 1, and then I'm going to notice that I have a positive back here, which means my two factors have the same sign. So I'm going to go ahead and list my two factors like this. Now which sign do those carry? Look at the middle one, they both are positive. So plus plus means positive positive. Now we look at this first term. What can I multiply together to get x squared? Well, there's really only two numbers. X times x will give you x squared. Then we look at the last term. What numbers can I multiply together to get 15? Well, there's a couple different options. We can do 1 times 15, so we're listing the factors. Or I can do 3 times 5, and that will also give me 15. So which set of factors do I use? Well, that depends on what the b value is. In this case, the b value is 8. So I want the sum of my factors to add up to 8. So which of those factors adds up to 8? 1 and 15 or 3 and 5? And clearly it is going to be 3 and 5. So the two factors I need are 3 and 5. And this ends up being the factor form of the original trinomial up here. And if you're ever unsure, you can always take your x, times it by x, and you get x squared. Take this x, times it by 5, and you get positive 5x. 3 times this x gives you a positive 3x, and 3 times this 5 gives you a positive 15. And then when you combine your like terms here in the middle, bring down my x squared, you'll see you have a positive 8x and a plus 15. So this matches the original problem. That's how you know that your factor form right in here was accurate. Example 2, we're going to try this again. I'm going to set up my parentheses. So parentheses here, set up my parentheses there. Notice that this back here is a negative. What that's telling me is one of my factors is positive and one is negative, because the only way I can get a negative product right here is to have opposite signs. Now my leading coefficient is 1, or 1x, so the only way I can get an x squared is to have an x times an x. Then we come back to our c value, which is 24, and we list the factors of 24 that will add up to 5. So if I would list them all, I can do 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now remember, one of these numbers is negative and one of these numbers is positive. So if I'm adding together the signs that are opposite, I'm technically subtracting. So what I'm really doing is looking for the factors of 24 that have a difference of 5. And if you look closely, you can see that 3 and 8 have a difference of 5. Now, do I put the 3 in the front, or do I put the 3 in the back? Well, that depends. If we go back and look at this, we see that the middle number is a positive. That means that the larger of the two factors has to be positive. Well, 3 is not the larger of the two. 8 is the larger. So that means that 8 needs to be in the positive position and 3 needs to be in the negative position, so that when I actually add these two numbers together, I still have a positive 5. So if all is done well, this should be my factored form. And if you're ever unsure, you can still distribute this out. So I have x times x, that gives me x squared. X times negative 3, that gives me negative 3x. Then I have an 8 times x, which gives me a positive 8x. And then I have an 8 times negative 3, which is negative 24. And when we combine the middle terms, x squared, negative 3 plus 8 is going to be a positive 5x. And I have a minus 24. And you can see that this matches the original problem. That's how we know that this is our fully factored form. Example 3, we notice that I have a leading coefficient of 1, so we're good on that. So I'm going to go ahead and set up my binomial parentheses. I look back here and notice that's a plus 12, or plus. That means the sign of my two factors are the same. This one tells me that they're both negative. So I can put a minus and a minus, or negative negative. The only things I can multiply together to get an x squared would be an x and an x. And then we want to list the factors of 12 that will add up to a negative 7. And the reason I know that they're going to add up is because the signs here are exactly the same. So they're both negative. So the factors of 12 that make a negative 7. Off the top of my head, I can think negative 3 and negative 4. Or put my 3 here and my 4 there, and I end up with a negative 3 and a negative 4. Now in this case, it doesn't really matter which one you put first. I could have put the 4 here and I could have put the 3 here. Because they're both the same sign, they will still come out to the same answer. This is my factored form. Example 4, leading coefficient is still 1, which means I can just drop down into my parenthesis binomial setup. The last term tells me that it's a negative, meaning the two signs are opposite. So I have one positive and one negative, which means I'll have two factors. One is positive, one's negative, but since the middle term is still a negative, I need the bigger term, or the bigger factor, to go there. So I want to know, what are the factors of 12 that will add up to a negative 4? It's actually factors of negative 12 that will add up to negative 4. So since I'm adding two signs that are different, one's positive, one negative, that means I'm actually subtracting. So what are the two factors of 12 that subtract or have a difference of 4? So off the top of my head, I believe a 2 and a 6 have a difference of 4. But remember, I need the bigger one to be negative so that I still have a negative number here. So I put my bigger number, which is 6, here, my smaller number, which is 2, here, and again, the only way I can get x squared is to put an x times an x. Now to double check to make sure that this is actually accurate, I'm going to go ahead and multiply this out. So x times x gives me the x squared. X times the negative 6 will give me a negative 6x. 2 times the x will give me a positive 2x. And 2 times the negative 6 will give me a negative 12. Now when I go and combine my like terms, I bring down my x squared. This right here combines to make a negative 4x. And of course I just bring my minus 12 down. And if you look at this here, you'll notice it looks exactly like the trinomial we had up there.